Trigonometry is what we're doing today. We can only use what we're doing today. It's called SOHCAHTOA. We can only use that with right triangles. We're going to learn more about trig later, where it doesn't have to be a right triangle, but all the stuff we're learning for the rest of, basically for the rest of this week, is going to be all about right triangles. Okay? So these are little parts of the triangle that you'll hear me say. If you see this little zero with a slash through it, it's called theta. So it's like a variable for an angle. That's pretty much what that is. So if you ever hear theta, it's kind of like a Greek word for it. Okay, we know what a hypotenuse is, along a side across from a 90-degree angle. And then these two might be a little new. So I know you've seen this word before, adjacent. So adjacent is going to be the side touching the angle we're talking about, whether it's theta or whether they actually give you a number. And opposite, we've done the opposite side. So it's across from your theta. So I'm not going to do all 6 of these, but your triangles can be facing any way. So no matter what way they're facing, it just depends on which angle they're talking about. Okay, so sometimes they'll give you all 3 angles where you just pick one. Theta is just not going to be the 90-degree angle. That's all. So theta can be here or here. If they give you all 3 angles, you get to pick whatever angle you want to use. If they only give you one like this, then you have to use this. So obviously the hypotenuse is the easiest thing to find. The hypotenuse you guys have been finding for a while now. Okay, now if I'm talking about this as your theta, it's going to be touching the adjacent side. It's also touching the hypotenuse, but we know that this is the hypotenuse. So the other side it's touching is going to be your adjacent side. And then opposite of theta is literally the opposite. Okay, so you have to be able to pick out these 3 pieces. You have to know the hypotenuse, which is the easiest. And then the adjacent is going to be the one touching theta. Opposite is opposite of theta. So if they give you theta up here, obviously you want to just go for the hypotenuse first, because that's going to be the easiest to find. So there's my hypotenuse. If I'm talking about this angle, this theta, then the one touching it. So I got the hypotenuse side touching it, but I also have this side touching it. So this will be my adjacent, and opposite of theta is literally the opposite angle. Okay, so if we're talking about this one, again, find the hypotenuse first. That's the easiest. If you circle it, the other side it's touching is your adjacent, and opposite of it is the opposite. Okay, so you have to be able to find those 3 pieces, because that's where we're going to start talking about this. So if you've ever heard of SOHCAHTOA before, that's just an easy way to help you remember these formulas right here. So in other words, sine, we're going to have sine, cosine, and tangent. That's what we're talking about here. So it's not sin. Everybody always says sin, but it's just short for sine. They just take the E off. So this is sine, cosine, and tangent. So the S stands for sine. And sine is supposed to be, this is like your formulas. So sine is the opposite side over the hypotenuse side. So that's what the O and the H stand for. This is the opposite side, and this is the hypotenuse. Okay, so it's just like an anagram to help you remember it. So this one, cosine. This stands for cosine. The A stands for adjacent, because this is the fraction you're going to use for cosine. You're going to put the adjacent side over the hypotenuse. So the adjacent over the hypotenuse, that's what that stands for. And then TOA, this is going to be tangent. You're supposed to use the opposite side over the adjacent side. So that's what all of these things stand for. Okay, so if you can remember SOHCAHTOA, that's the easiest way to remember it. Otherwise, you just have to kind of memorize your formulas. So this is what we're dealing with all day today. So sometimes they're going to ask you for the ratio. If you see the word ratio, that's a fancy word for a fraction. So they want to know the ratio of these. So these first ones, you don't really have to find the actual answer. You're just finding me a ratio. You're just finding me a fraction. So whatever angle they have here, that's going to be your theta. So these 3 are going to have A as your theta. Okay, so in this case, if I'm going to do these ones in red, in this case, obviously across from your 90-degree angle, that's your hypotenuse. So you want to label these. It just makes life easier. And then this would be the opposite. And then this would be the adjacent. Okay, so if I'm finding the sine of A, sine, remember we did the opposite over the hypotenuse. That was the SOH, so in the SOHCAHTOA. So sine is opposite over hypotenuse. So that's what I'm doing. So the opposite is 9 over the hypotenuse, which is 15. And then you just have to reduce. So both of these are divisible by 3. So your ratio is 3 to 5. Okay, and then cosine, so ca is adjacent over hypotenuse. So we're supposed to be doing adjacent over hypotenuse for cosine. So the adjacent is 12. The hypotenuse is 15. And again, divisible by 3. So 4 to 5 is going to be your cosine. Tangent, the TOA, is opposite over adjacent. So I'm looking for the opposite, which is 9, and the adjacent, which is 12. Again, divisible by 3, so always reduce a fraction if you can, and that's going to be 3 to 4. Okay, now it's the same thing for the other ones, except this time we're using a different angle. So this time for these ones, I'll use green for your B. This time B is your theta because all of these have B's with them. So in this case, the hypotenuse never changes. It's always across from the 90-degree angle. But in this case, now this one's the adjacent, and now this one is opposite of theta. So you have to pay attention to the angle so that you can figure out which one the adjacent and hypotenuse are. So same thing, opposite over hypotenuse for sine. So that means it's going to be 12 over 15 for the sine of B. And reduce divisible by 3, which is just going to be 4/5. Cosine is supposed to be adjacent over hypotenuse. So that means it's 9 over 15, which is 3/5. And tangent is opposite over adjacent. So I've got 12 over 9 for that one, which is going to be 4 over 3. Okay, so that's what you're doing with those. It just pay attention to what the angle is. So that's going to tell you what theta is. Okay, I did another one for these. I probably don't need to do them all, but if you do the A's are going to be here. Okay, so I'm going to do opposite over hypotenuse. Here's my hypotenuse. My opposite is here, and my adjacent is there. So if I'm going to do that, I'm going to do the opposite over the hypotenuse. So 30 over 34. And if I divide that by 2, that's going to give me 15/17. Cosine is adjacent over hypotenuse, 16 over 34. Reduce that is 8 over 17. And tangent is opposite over adjacent, so 30 over 16, which is going to be 15 over 8. Okay? Then when you do the B's, you just have to switch to this being your theta, and you'll have to switch the adjacent and the opposite. So it's the same thing. So that's when you see the word ratio. If they want the ratio of sides, that's what they're talking about. They just want a fraction. Okay? Now, same thing here. If you want to find the exact value, these were our special right triangles, right? This was what we were dealing with last week before when we did the 45, 45, 90 and the 30, 60, 90. So if they give you stuff like this and you're not supposed to put it in the calculator because these are the special right triangle numbers, 30, 60, and 45s. So these are going to be our thetas here. So if we're talking about 30, sine of 30, that would make this theta. So here's my hypotenuse, here's my adjacent, and here's my opposite. So if I did sine of 30, I got to do opposite over hypotenuse. So I would have x over 2x, and the x's would cancel out. You just have a half. Okay? If I did the cosine of 30 is supposed to be adjacent over hypotenuse. I used z's before, but it doesn't matter because the z's will cancel out just like the x's will cancel out. So you're just going to have square root of 3 over 2 for that one. And then tangent of 30, that's supposed to be opposite over adjacent. So I've got x over x squared root of 3. And these go away, so you're left with 1 over the square root of 3. Now, just like before, you're not allowed to have a square root at the bottom of a fraction. So you would have to rationalize like we learned in the middle of last week. So then this would actually be the square root of 3 over 3 for this answer. Okay, now if you did 60s as your theta, so if I did that, that would make this the adjacent and, oh, I'm sorry, that's still the hypotenuse. That would make this the adjacent, and that would make this the opposite. So I'll do the 60s in blue. The sine of 60, opposite over hypotenuse, so x squared root of 3 over 2x. The x's go away, so you're just left with the square root of 3 over 2. If I do cosine, cosine is adjacent over hypotenuse, so x over 2x, which is a half. The x's go away. And tangent of 60 is going to be opposite over adjacent. So x squared to 3 over x. And the x's just go away. Okay? Finally, we'll do the 45s. So now we got to go over here to 45. They're both 45, so you get to pick. Doesn't matter which one you pick for your theta. If you pick this one, it's going to be the same as if you pick that one, because the opposite and the adjacent are the same anyway. So it makes no difference because they're going to be the same thing. Okay, so if I do sine, sine is supposed to be opposite over hypotenuse. So I've got x over x squared root of 2. And then the x's go away. And you have to rationalize. So I times by the square root of 2, that's going to be 2 on the bottom, square root of 2 on top. Cosine of 45, adjacent over hypotenuse, it's the exact same thing. You would still have x over x squared root of 2. No need to figure out that. We're just going to keep the square root of 2 over 2. And tangent is opposite over adjacent. So you have x over x. That doesn't mean it's 0. It just cancels out because it equals 1. Okay, so that's usually when it cancels out if it has something else in front, because you usually don't write the 1 in front. Okay, so that's if you see these ones with the 30, 60, or 45, those are your special numbers that you got to pick out. Now, if you have these ones where it literally tells you to use a calculator, if it tells you to do that, then you are allowed to do that. The other ones, I'll be looking for square roots. These ones, when it tells you to round, these are the ones you get to put in your calculator. So the special rules for your calculator, you got to go in here and you need to go and change the mode. If you do not do this, you're going to get decimals and you're not going to know that they're wrong. Okay, so you have to hit the mode. You have to make sure that degree is highlighted because we're going to be doing these in degree. Radians come later. So degree is what you need to highlight and hit enter. That way, if degree is highlighted, you're good. You're in degree mode. Okay? So now what I can do is just type it in. Here's sine, cosine, tangent. So if you just put in sine of 5 and hit enter, what did it want to the nearest 10,000? So this is tenths, hundredths, thousandths, 10,000ths. They want 4 decimals. So that would be 0.0872 for that one. And that's all you have to do is stick these in the calculator. As soon as I get my pen to work. Okay, so that's all you're really doing for these. When you're using the calculator, they want to make sure that you are in degree mode. Next one, I've got sine of 75.8. Well, that's one below it. But so if I round to 4 decimal spots, I got 0.9694. And that's all we're doing with these. Okay. Now down here, if it says find the measure of the angle, notice the angle is the one that's missing. So this is usually your theta. So to find this, what you have to do is you have to use the inverse. So for that one, I'm going to write you a little note. If you're looking for the angle, you're going to use the inverse. And we'll talk about this more tomorrow. When I say inverse, that means the one with the negative. See how in blue, it has a -1 power? So if I'm looking for the sine of b of this, I'm going to use the inverse of sine. So I'm going to use the blue one. It's going to pop up with that little -1. The other one didn't have that. So this has a little -1 there. And I got to put all those decimals in. You can't leave any out. So if I put all those in and hit enter, we're going to get the degree. Now this one says the nearest tenth of a degree. So tenth is the first decimal. So I'm going to have 17.4 degrees for that one. Okay, so if you're looking for the angle, make sure you use the negative, the blue one. All right, for this one, I'll do one more for the tangent. So I have to do the inverse tangent. That's the blue one right there. Make sure you have a little negative if you're looking for an angle. And I got 0.3894. Rounding to the nearest tenth, that's going to round up to a 3. So 21.3 degrees for that one. Okay. These are the problems you'll be used to seeing. So I got a bunch of these. I don't know if I'll go through all of them or not. These are the ones where you're actually going to solve. So the only way you can do this is with SOHCAHTOA. Okay, so I've got a 28-degree angle. That is my theta. So if that's my theta, the first thing I want you to do is start marking stuff. So here's my hypotenuse. Here is my opposite. And here is my adjacent. So there is no hypotenuse. There's no number there. There's no letter. There's no nothing. So I need something with opposite and adjacent. So if I write SOHCAHTOA up here, The only one that has an opposite and an adjacent, and that's it, is TOA. So that's tangent. So that's going to tell me which trig function to use. Okay, so I'm looking at tangent. My degree goes next, tangent of 28. And then I'm supposed to do opposite over adjacent. So I'm going to do x over 32. And then I'm supposed to solve for x. Now to solve for x, they divided by 32. So to solve, all you got to do is times it. Like this. And that's going to give you my answer. Again, you must be in degree mode for these to work. So I'm going to do 32 times the tangent. And you can hit the times button, but you don't have to. So 32 times the tangent of 28. And you don't have to close the parentheses if you don't want to, because there's nothing after it. It doesn't matter either way. You get the same answer. So in this case, we're going to round to the nearest tenth, and it's just going to be 17, 17.0. Okay, these are the ones that I'm going to really focus on. Okay, so I've got theta right here. Here's my hypotenuse, easiest to figure out. The other one touching theta is going to be your adjacent. And then this is my opposite. So this time, there's no numbers, no letters, or anything for opposite. So what I have is adjacent and hypotenuse. So adjacent and hypotenuse is cosine. So cosine of your angle, 33, is supposed to be the adjacent over the hypotenuse. So that's x over 19. Okay? And then you solve for x. So my next step is, since they're dividing x by 19, I'm going to times. So I got 19 times the cosine of 33. And that's going to give you about 15.9 for your answer. Okay. Next, here's theta. Hypotenuse is the easiest to figure out. The other one theta is touching is adjacent. And then this last one will be your opposite. Okay, so the one that doesn't have a number or letter or anything is your adjacent. So I have opposite and I've got a hypotenuse. So that is my sine value. So I gotta have the one with the O and the H in it. The only one that has that is the sine. So you really need that SOHCAHTOA stuff. So this will be sine, put the degree, put the theta next to it. And then it's opposite over hypotenuse. Okay. Now, this time when we're solving for x, you can't really get rid of the 16 yet. You usually always have to get rid of a fraction first, which would mean you got to times by x. Okay, and then you just have to turn around and you have to divide by the sine of 40 to get x alone. So I'm going to do 16 divided by the sine of 40. Basically what happens here is if you get x in the denominator, you can just swap them. You just swap them every time. So what I've got is 16 over the sine of 40. And that's going to give me about 24.5. Okay, theta. Here's my hypotenuse. Here's my adjacent. And the one opposite of theta is your opposite. So there is absolutely no letters, no numbers, no anything on the opposite. So I want the one with A and H, and that is cosine. So I'm going to do cosine of 64. And it's supposed to be adjacent over hypotenuse. So 15 over x. Again, you don't have to go through these steps. If you've got the x on the bottom, just swap these. So if I swap them, it's going to switch around to this. And then I just need to plug in 15 divided by the cosine of 64. And that's going to give me about 34.2 for this one. Okay, that is our main, that's basically what we've got going on here. Okay, so I've got a couple of extra examples. I think I have 4 more, and then that's it. So I know it was a little long today, but I wanted to do a bunch of examples. Okay, I've got my hypotenuse. That makes this the adjacent, and this the opposite. So the one without anything is right here. I want the O and the H, and that's SOHCAHTOA, that's S-O-H. So that's sine of 25. Always put your degree there. Opposite over hypotenuse, so x over 13. And then you can solve for your x. So to get x alone, times by 13. Okay, instead of plugging the calculator, I'm just going to keep going, just so I can get through these. So this is my hypotenuse. That makes this the adjacent and this the opposite. Okay, so the one missing here, there is nothing for the hypotenuse. I've got an O and an A. That is tangent of 32. And that's opposite over adjacent. So 71 over x. And then you'll just have to swap these. So when you plug it in your calculator, you should be plugging in 71 over the tangent of 32 and get whatever your decimal is. All right, last two. Here's my hypotenuse. The other one touching theta is adjacent. One missing this time, there's nothing on the opposite. I need an H and an A, which is cosine of 21. And you're supposed to do the adjacent over the hypotenuse. Okay, again, x is on the bottom, just swap them. So I got 24 over cosine of 21 that I plug in my calculator. Last one, hypotenuse. Other one touching the theta is your adjacent. And my opposite is the last one. So nothing for hypotenuse. The only one with an O and an H is TOA. So that's tangent. Tangent of 56 is opposite over the adjacent. Okay, so when you multiply, so that I can get my x alone, times by 56 to get your decimal. Okay.